Hey folks, Mr. Dell here. We are going to be simplifying rational expressions, is what we would call some of these, but expressions that have exponents, right? Using some of our exponent rules. So this is a problem that I'm pulling from some examples from CPM's course 3, and this is section 10.1.2. So it says simplify each expression. So here I have 5 to the third over 5 to the ninth, right? If I want to just understand what I'm dealing with, 5 to the third means 5 times 5 times 5. 5 to the ninth means 5 times 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 5. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 times 5. So in the numerator, I have 3 fives being multiplied. In the denominator, I have 9 fives being multiplied. So what really is occurring is what you can do is when you have all this multiplication, you can factor out giant ones, right? Because if it's all multiplication, that 5 over 5 can factor to be a giant one. I can in a sense cancel out those 5 divided by 5, which is 1. So what we have, you always have something left on top. You can't all of a sudden the top completely disappear. There's always this times 1. So the numerator becomes a 1, and the denominator is 5 times 5 times 5 times 5 times 5, which is 5 to the 6th. We can multiply 5 to the 6th out and figure that out, or I can just leave it as a fraction, or leave it as an exponent. So this is the answer, one of the answers, and one of the methods. But I also want to remind you of the one of the rules we learned is that if you have a x to the a and you're dividing by x to the b, right? You have like bases and you're dividing them. What that means is you subtract the exponents, x to the a minus b. But what I tend to do is I look to see, okay, if I see here, if I went 3 minus 9, so if I rewrite this question, x to the third over 5 to the 9, and I used this rule, I would go 3 minus 9. So I'd get 5 to the negative 6. But we don't want negative exponents. Negative exponents create reciprocals, right? A negative exponent creates a reciprocal, so it's 1/5 to the sixth, and 1/5 to the sixth is really just 1 to the sixth, which is 1, 5 to the sixth on the bottom. So that's how it also becomes that. Sometimes a quicker way of looking at it is when you have division of like bases, subtract normal, big minus small, but where you have more is where you end up with your answer. So I can look at it that way too. So all in all, this is the answer for A. B. So B, notice again, if I'm gonna break it out, I could actually see what this means is on the top I have AB times AB times AB, oops, AB times another AB, right? Because it's AB all to the fourth. So AB times AB times AB times AB. And then on the bottom, this says AB to the third. So the 3, the exponent of 3 only affects the B. So what that means is A, B, B, B. So now I can consider canceling out or dividing out any giant ones. Here I have a set of A's, right? That divides out. A set of B's divides out. Let's see, another set of B's right there and there. And then this B and that B can divide out, right? So what's left? Once I divide it out, I have an A, B, A, B, or A. So really what I have is 1, 2, 3 A's left over. So that's A to the third and a B. And then only a 1 on the bottom, but really don't need it. So we'll just say A to the third B. So again, that's one way of simplifying. The other I want to point out, and I want to point out all the different rules that we've learned here. Another rule we learned is x to the a all to the b is equal to x to the ab, meaning if I have a power to power, exponent to exponent, I would actually multiply the exponents. So if I was going to take this same problem, and I'm going to do it again, I'll do it again up here. Take this same problem, and I'll rewrite it. ab to the fourth over ab all to the third. And I use this rule. This right now immediately becomes a to the fourth b to the fourth, right? Do you see? Because a to the first, b to the first. These are right now a to the first, b to the first. So I'm going to actually multiply their exponents like I have to do here. Power to power, multiply exponents. So it becomes a to the fourth, b to the fourth. And now on the bottom, this is still just a, b to the third. And now I can go back to using this rule, which is subtraction. If I divide out like bases, a to the fourth divided by a to the first, subtract, gives you a to the third, and it's left on top because there's more a's on top. B to the fourth divided by b to the third, 4 minus 3 is 1, so it becomes b to the first, and it's on top because there's more b's on top. And that's all over 1 again, or just written like that. Okay? All right, let's keep going. This guy here. So what we've got is I've got this 8x to the negative 3 and as well 8x to the second. So I'm going to take this one in first. Anytime you have a power to power, you always deal with that first before. It's like deal with your exponents before multiplication. Because what's going on between these two is just multiply. That 2 only affects this 8x. So this becomes 8x to the negative 3, doesn't change. I'm going to put in parentheses just for that matter. And then this now becomes 8 to the second, x to the second. Remember, the 2 affects both the 8 and the x because they're covered in parentheses there, and the 2 is on the outside of parentheses. So now once I did that, I used this rule here, right, for this. Now I'm going to remind you of another rule, and that's if I have x to the a times x to the b, right? If I'm multiplying like, oops, I meant to be an x, sorry, x to the b. If I multiply like bases, x to the a times x to the b, it means x to the a plus b. You actually add the exponents. So this is now multiplying. Everything's multiplying straight across. So it's 8 to the first times 8 to the second makes that 8 to the third. X to the negative 3 times x to the positive 2. You can add those. Negative 3 plus 2 is negative 1. So here's what I have so far. 8 to the third times x to the negative 1. Now that negative 1 only affects the x. And remember, negative exponents change to positive once the base becomes its reciprocal. So this is 8 to the third times 1 over x, and 1 over x all to the first, right? It's actually all to the positive 1 now, because once you make that base a reciprocal, it changes the exponent to be positive. So let's clean this up a little bit. So this is actually, I'm going to put that over 1, multiply straight across, so I get 8 to the third over x. And I can leave my answer that way, or I can multiply 8 times 8 times 8. So far, so good. That was C. I'm almost out of room, but D, here we go. D, I have 1 over, or 1/6 all to the fifth. So I'm gonna clean that up first. Before I multiply, I got to deal with if there's exponents, and I have exponents here, so that's 6 all to the third. So this looks like this. So I'm going to take the 1/6 and make it to the fifth. So that means 1/6 times 1/6, so that's 1 to the fifth, 6 to the fifth, right? 1 times 1 times 1 times 1, all on top. 6 times 6 times 6 times 6 times 6, all on the bottom. And then I'm multiplying that times, 6 to the third. I can just write it as 6 to the third. But because I have a fraction over here, I'm going to make that into a fraction. So now I have this 1 to the fifth, which again is just 1, times 6 to the third. So I'm going to write it 6 to the third. And then 6 to the fifth times 1, which is 6 to the fifth. Again, now I dealt with multiplying them out, and now I'm looking at a division, right? Back to this. I have the division of like bases, subtract the exponents. So if I divide like bases, so I'm going to subtract this way, though. I'm going to say 5 minus 3, and I get 2. But where are there more 6s? There's more 6s in the denominator, so that 6 to the second goes to the bottom, and what's still left up is a 1 on top. So final answer could be 1 over 6 squared, or 6 squared is 36, so I can multiply that out. Either way you look at it. Okay? There we go.